Hello everyone, welcome to the session on physical sensors and sensitivity. I am Ms. S.V. Goklavashini, Assistant Professor in the Department of Food Technology at SNS College of Technology. So today we will explore what physical sensors are and why they are so important and how sensitivity and specifically what makes them too reliable in the real world application. So let us dive in. So physical sensors are everywhere, from the smartphone in your pocket to the equipment on major factories. So in fact, the global physical sensor market was worth $16 billion in 2023. So what makes them so important is that they help us translate physical phenomena like heat, pressure, light or motion into measurable data. They are the backbone of automation, safety and data-driven decision making. So to simply put, physical sensors are the devices that are responsible for the physical inputs. Their job is to convert from one of the energy into another, a process we call transduction. So some common examples you may know include temperature sensor, pressure sensor, motion detectors and light sensors. So together they help us control and monitor the complex system with the precision. So temperature sensor are probably the most wide sensors used. So let us see about the two types. So first is RTDs. So resistant temperature detectors, they use platinum, usually platinum 100, and offer a linear response over a wide range from minus 200 degrees Celsius to 850 degrees Celsius. So they are highly accurate with a margin of plus or minus 0.1 to plus or minus 0.3 degrees Celsius and extremely stable over the time. So the thermistors, these are the semiconductors based and very sensitive. So the resistance changes from 3 to 5% per degree, making them ideal for applications where rapid response is needed. For example, in medical thermometers, they use the thermistors. So pressure sensors are another cornerstone. So strain gauge sensors and piezoelectric sensors. So these are the main two sensors. On speaking about the strain gauge sensors, they measure the deformation caused by the pressures. And these sensors are highly accurate within 0.05% of full scale and are used in load cells and process the control systems. And when you are speaking about the piezoelectric sensors, these generate a voltage when subjected to the mechanical stress. So they are extremely fast and they respond in microseconds and are perfect for detecting rapid pressure changes, such as it is used in engine knock detections or medical ultrasounds. So now let us talk about sensitivity, one of the most important matrices for the sensors. So sensitivity is simply the smallest change a sensor can detect. For example, if a temperature has a sensitivity of 0.1 degrees Celsius, it will reliably detect even a tiny 0.1 degrees Celsius change. So this is crucial for high precision measurement and for detecting early changes, and such as warning signs in machinery or patient health. So specificity is about accuracy in complex environment. It is the ability of a sensor to measure, adjust the parameters we want, ignoring everything else. So for instance, a temperature sensor should measure the temperature, which is not to be affected by the humidity or electromagnetic noise. So this ensures the reliable data even in multivariable noisy environment, something very important in industrial and medical applications. So let us see how this works in real life. So in hospitals, sensors continuously monitor patient vitals. So high sensitivity thermistors more core body temperatures to the accuracy of plus or minus 0.1 degrees Celsius, while strain gauge pressure sensor measure the blood pressure within the margin of just plus or minus 2 millimeter per Hg. So this precise reading helps the doctor to make a life-saving decisions and avoid false alarm. So now think of a chemical reactor in a factory. RTDs precisely monitor the temperature to within plus or minus 0.5 degrees Celsius, keeping the exothermic reaction safe. At the same time, strain gauge pressure sensors ensures the reactor does not exceed the safe pressure limits. So together, they prevent the accidents, improve the yield, and ensure the compliance with the food safety standards. So Next, we shall look upon the physical sensors which are evolving very rapidly. So, miniaturization has led to the MEMS sensor, which is small, cheap, and efficient. So, integration with the IoT is creating billions of connected devices worldwide. So, AI and machine learnings are now being used to analyze the sensor data, prediction of failures, and enable preventive maintenance. And with the new material, we are seeing even greater sensitivity and specificity than before. So, to wrap up, physical sensors truly are the silent enablers of a modern technology. They provide precision, safety, and efficiency, everything from healthcare, food, industries. So, and as we move forward, innovation in materials, AI, and IoT will only make them more powerful and intelligent. So, thank you for watching. If you found this helpful, don't forget to like, share, and this video.